If you've used the internet at all today, and hey, you're watching this, so you definitely have, then you've almost certainly bumped into a piece of technology called Nginx. It's the silent engine behind hundreds of millions of websites, including absolute giants like Netflix, Google, and Apple. But this isn't just a story about some popular software. No, it's the story of a revolutionary idea that solved a problem that was on the verge of breaking the entire internet. Okay, let's dive in.
Our story really kicks off with a simple question that had, well, a terrifyingly complex answer. Back in the late 90s, the web was exploding, but the technology powering it was hitting a wall. A very, very specific wall. People started calling it the 10,000 connection problem.
To really get why the solution was so brilliant, we first have to understand the crisis. See, the web was growing way faster than the servers could keep up, and a single, fundamental flaw in their design was about to bring high-traffic sites grinding to a halt. And here it is. This is the villain of our story, the C10K problem. That C stands for connections, by the way. And here's the crucial part. This wasn't a hardware issue. People weren't running out of processing power. Nope. The problem was buried deep in the software's DNA and how it was designed to think. So the flaw was simple, but it was fatal at scale. Servers like Apache, which was the big dog at the time, used a pretty straightforward model. One visitor, one dedicated process or thread. For a few hundred visitors, fine, no problem. But for 10,000? Oh, the server would just grind to a halt, drowning in memory usage and the ridiculously inefficient task of constantly switching the CPU's attention between thousands of waiting connections. It just wasn't built to scale. The web needed a hero, a completely new way of thinking. And that hero was a Russian developer named Igor Sysoyev, who decided to solve the problem not by throwing more power at it, but with a much more elegant design. And this is so key. Nginx wasn't born in a lab. It was forged in the fire of real-world demand. Sysoyev actually developed it for some of Russia's busiest websites. So by the time it was released to the rest of the world, it had already proven it could handle massive scale. We're talking 500 million requests a day. So what was the secret? Well, it was a complete paradigm shift. Instead of that one-person, one-cashier model of the old servers, Nginx used something called an asynchronous, event-driven model. It's kind of like having one incredibly efficient chef who's handling dozens of orders at once, never just standing around waiting for one to finish before starting the next. Okay, let's break that down. Think of it as a conductor and an orchestra. First, a single master process. That's our conductor. It starts up, reads the instructions, and then it launches a small, fixed number of worker processes. Its only job from then on is to manage these workers, making sure the music keeps playing even if one of them stumbles. And this is where the magic happens. These are the orchestra members, the worker processes. A single worker never ever waits for any one connection. It essentially tells the operating system, hey, I've got thousands of connections to watch. Don't bother me, just wake me up when one of them actually needs something. By never waiting, a single worker can efficiently juggle thousands upon thousands of connections, using system resources with just incredible precision. And the result of this brilliant architecture, get this, 2.5 megabytes. That's roughly how much memory Nginx uses to handle 10,000 inactive connections. I mean, that is an order of magnitude less than a traditional server. It's not just an improvement, it's a completely different class of efficiency. This radical efficiency meant that Nginx wasn't just a better web server. Its core design, being this super fast, lightweight traffic cop, allowed it to evolve into something much, much more versatile. Today, Nginx is like the ultimate digital Swiss Army knife for developers. I mean, yeah, it's a fantastic web server, but it's also a reverse proxy that protects and routes traffic, an intelligent load balancer that keeps sites reliable, a cache that speeds everything up, and it's even a critical entry point for modern Kubernetes applications. This versatility is exactly why it's so fundamental to the web today. So, we have this revolutionary architecture and this incredible versatility. But did it actually work? Did it win the war for the web? Oh yeah. The data tells a very, very clear story. The choice between Nginx and its main rival, Apache, really boils down to a difference in philosophy. Nginx is built from the ground up for raw, centralized performance. Apache, on the other hand, was built for decentralized flexibility, which was perfect for an earlier, simpler era of the web, but it became a huge performance bottleneck under heavy load. And the data tells the whole story. Just look at this trend here. The higher the traffic, from the top million sites all the way to the elite top 1,000, the more Nginx dominates. The world's busiest, most performance-critical websites overwhelmingly choose Nginx. The market is voted with its traffic, plain and simple.
This quote just nails it, doesn't it? When every millisecond and every byte of memory counts, when performance isn't just a feature but a core business requirement, the choice becomes pretty clear. All right, the final chapter in Nginx's rise from a niche open-source project to a pillar of the internet came in 2019, with an endorsement you can put a very large number on. $670 million. That's the price that networking hardware giant F5 paid to acquire Nginx. But this number, believe me, it represents far more than just money. See, this acquisition was a landmark event for the whole industry. It was a clear signal that the future of delivering applications was moving away from expensive centralized hardware boxes and toward flexible, developer-friendly software. For F5, this was their strategic bridge into the future. It gave them instant credibility with developers, it accelerated their move into cloud services, and it allowed them to pair their world-class security with Nginx's legendary performance. It was a bet on the software-defined future of the web, and Nginx was the absolute centerpiece.
You know, the story of Nginx is just this powerful reminder that sometimes the most profound innovations aren't about brute force, but about elegant design. An idea that was born just to solve one critical bottleneck ended up reshaping the architecture of the entire internet. And it leaves us with a pretty big question. What is the next great bottleneck hiding in our digital infrastructure? And what brilliant, simple idea will be the one to solve it?